Welcome to third episode of our complete Python tutorial. This tutorial provides a foundational overview of key Python concepts, laying the groundwork for further exploration in this versatile programming language. It provides a solid foundation by covering essential concepts like variables, data types, operators, and control flow. Let's delve into the core elements covered. Comments are essential for making code more understandable for both the programmer and others who might interact with it. Comments are primarily used to add human-readable explanations to your code. They help you and other developers understand the purpose, logic, and functionality of specific lines or blocks of code. You can also use comments to temporarily disable parts of your code during debugging or testing. Commenting out a line prevents it from being executed by the interpreter or compiler. Python offers two primary ways to incorporate comments: single-line comments and multi-line comments. The most common way to create a single-line comment is by using the hash symbol at the beginning of the line. This effectively comments out the rest of the line, making it non-executable. Everything after the hash symbol on that line will be ignored by the program. Executing this line will not result in anything because it is just a comment. This method can be used to comment in the same line where code is written. When the code is run, comments are ignored by the compiler. This is a simple way to explain one line of code using comment. This method is also used to temporarily disable a line of code. This is commonly done for debugging, testing, or identifying errors, but there can be another reason as well. Multi-line comments are mostly added using triple quotes to explain the code or logic in detail, or disable a large portion of code. This allows for comments spanning multiple lines, improving code organization and readability, especially for explanations or documentation within the code itself. When you run the program, codes are executed, and comments around the code are ignored. Variables in Python are containers for storing data. Their data types, like integers, floats, strings, etc., determine how the computer handles and processes that data. In Python, variables are declared by simply assigning a value to it using the equals operator. Python can automatically determine the data type of a variable. Python supports various data types, each designed to represent different kinds of information, such as integer, string, float, boolean, etc. Integers represent whole numbers including positive, negative, or zero. Integers are used for mathematical operations, like addition, subtraction, multiplication, and division. You cannot perform operations that are not compatible with the data types involved. For example, you cannot directly add a string to an integer. Floats represent numbers with decimal points. They are used for calculations involving fractions or more precise values. Strings represent sequences of characters, enclosed in single or double quotes. Strings are used for text manipulation, such as string concatenation, slicing, and formatting. Boolean represents truth values, either true or false. Booleans are used for conditional statements and logical operations. For example, here we test if x equals y, and store the result in variable z. The result should obviously be false, which is now stored in variable z. However, if we test if variable x equals variable y minus 1, and store the result in variable z, the variable z should now be true, as x and y minus 1, both are 4. Lists are ordered collections of items, which can be of different data types, enclosed in square brackets. Lists are mutable, which means they can be modified after creation. For example, let's change the item at index 2 in this list to ABC. Now, you will see that the item has been changed to ABC. Tuples are collections of items, enclosed in parentheses. They are similar to lists, but immutable, meaning they cannot be changed after creation. For example, let's try to change the same item in tuple we did in list to ABC. This time, it will result in an error, instead of changing the item. Dictionaries are unordered collections of key-value pairs, enclosed in curly braces. Items can have different data types in a dictionary. Unlike lists or tuples, items a dictionary cannot be accessed using index, because items are unordered. Instead, they are accessed using their key. And because they can be accessed using their key, they can be modified using their key as well. Just as here, we have modified the value of age from 30 to 40. You can use the type function to determine the data type of a variable. Let's define some variables and assign some values to them. Now, let's use the type function to identify their data type. Identifying data types can help us properly perform calculations and other operations. We can also convert the data type of a variable to perform certain operations. For example, if we want to get the first number of this integer, we cannot do that using index. But using a built-in function, we can convert its data type to string. And as a string, we can get its first number using index. There are thousands of other scenarios where you may need to change the data type of a variable. Operators are symbols that perform specific operations on values or variables. They are fundamental for controlling the flow of a program and making decisions based on data comparisons. Operators are further classified into operative, comparison, and logical. Arithmetic operators are used for basic mathematical calculations. They enable us to perform basic operations like addition, subtraction, multiplication, and division. They also provide specialized functions such as floor division, to obtain the integer portion of a quotient, modulus to determine the remainder after division, and exponentiation to raise a number to a specified power. Comparison operators are used to evaluate relationships between values. These operators return a Boolean result. They are crucial for various tasks, such as verifying if two values are identical, determining if they differ, comparing values to establish their order, smaller or larger, and checking if a value resides within a particular range. Logical operators are used to combine Boolean values to produce a single Boolean result. OR operator returns true if at least one condition is true. AND operator returns true only if all conditions are true. NOT operator inverts the Boolean value of a single condition. Control flow mechanisms allow the program to execute specific blocks of code based on conditions or to repeat actions. These control flow structures are essential for creating dynamic and responsive programs. If-else statement allows you to execute different code blocks based on whether a condition is true or false. You can use if-else statements to check user commands and execute the appropriate actions. For loop repeats a block of code for a specified number of times or iterates over a sequence of values. These loops are used for repetitive tasks. While loop is used to repeat a block of code as long as a given condition remains true. Such as, in this example, till the count is less than 5. And with this, we end this tutorial. Thanks for watching. We hope you liked our tutorial. Don't forget to like, subscribe, and hit the bell icon for more insightful tutorials and updates.